Welcome children. Today we'll see thermal physics part 3. In our previous classes we saw what is thermal energy, what is thermal equilibrium and what is expansion of solids, liquids and gases. Today we are going to see about gas. The gas is of two different types. That is, they are really classified as real gas and ideal gas. What is real gas? If the molecule or atom interact with each other with definite interatomic force of attraction, then it is said to be real gas. Whereas, if a molecule or atom do not interact with each other, then it is said to be ideal gas. At a very high temperature or low pressure, the real gases also behave as ideal gas because in this condition, there is no interatomic or intermolecular force of attraction. Okay, as I already told you, ideal gas is nothing but if an atom or molecule do not interact with each other, then is said to be ideal gas. Another name for ideal gas is perfect gas. No ideal gas is ideal because the molecules of any gas will have a certain amount of interaction among them. But these interactions are weaker when the pressure is low and the temperature is high because the interatomic or intermolecular forces of attraction are weak in an ideal gas. Hence, a real gas at low pressure or high temperature can be termed as a perfect gas. All these ideal gases obey the three laws: Charles law, Boyle's law and Avogadro law. So, because all these relates the pressure, temperature and the number of atoms present in the molecule. When there is a change in the state of the gas, any one or more of these parameters change its value. So, the above said laws relate these changes. Okay. Now we will see the ideal gas equation. The ideal gas equation is an equation which relates all the properties of an ideal gas. As I have already told you, the ideal gas obeys the three laws: Boyle's law, Charles law and Avogadro law. Boyle's law is a law in which at constant temperature the pressure is inversely proportional to the volume. Charles law is at constant pressure the volume is directly proportional to the temperature, and the Avogadro law is nothing but the volume of gas is directly proportional to the number of atoms or molecules present in it at constant pressure and constant temperature. After combining equation 1 and 2, that is, one is Boyle's law PV is constant and Charles law V by T is constant. So, after combining equations 1 and 2, we get the equation PV is equal to NT. PV by NT is constant. This relation is called combined law of gases. If we consider a gas which contain mu moles of the gas, the number of atoms contained will be equal to mu times the Avogadro number Na. So, N attains a value mu Na. Using this equation 5 in the above equation 4, we get PV is equal to, instead of N we use this mu Na, T is constant. Here, the value of constant in the above equation is taken to be Kb, which is called as Boltzmann constant, and the value of Boltzmann constant is 1.38 into 10 to the power of minus 23 kilojoule minus 1. So, the equation is again written as PV by mu NAT is equal to Kb, where Kb is nothing but the constant which is called as Boltzmann constant. Now, when you cross multiply this, you get P. So, the Boltzmann constant Kb is PV by mu NAT. So when you cross multiply, you get PV is equal to mu NA T KB. Here mu NA KB can be taken as R, which is the universal gas constant. So R is nothing but this part where mu NaKB, which is R, which is the universal gas constant, and its value is 8.31 joule mole minus 1 Kelvin minus 1. So when you substitute this R in the place of mu NaTKB, PV will become PV is equal to RT, which is the ideal gas equation. This ideal gas equation is the equation of state, as it gives the relation between the state variables, and it is used to describe the state of any gas. So I think now you are clear how we got the ideal gas equation PV is equal to RT. It is a very simple equation, but it is very important, which has been in many of your question papers. So please learn to derive this equation. Thank you, children.